Hello. So today I will give you some guide on the final exam. So this is not to tell you any answers, but this is a kind of extension of the lecture. And okay, so in the exam, it took more time than I expected because I wanted to make it kind of better. And my purpose, my intention is to show you the full steps from a model to identification issues and estimation issues, and you have to go through those steps, not the details. I'm not saying, I'm not asking you any proofs, but there are several steps. Just you need to check and apply existing results. So I'd like to show them step by step. So in the lecture notes was chapter by chapter. So it was like broken down, but now you should be able to do that in one question. Okay, and also uh, main purpose is to main purpose of this video is to save my time with grading and also save your time uh, wondering what you have to do in the exam. Also, additional warning, the exam may have a lot of typos as usual, right? So when something is unclear, ask me. That is totally fine. Or if you think something is certainly wrong, you can just add your assumption. Simplify the question. If you uh, do not have an idea what's going on, then and if you cannot handle the algebra, try to simplify things or ask me questions. Okay. So question one is about measurement error model, the error or errors in variables model. This is a modified question from a homework. And in the end, there are three structural equations. So now you learn simultaneous equations model. So it will be natural to think about this model as a kind of simultaneous equations model. There are three equations I specified in the question, right? This is production function, which is our main equation, and these are two equations to describe how a measure of capital input is generated, right? And then, of course, you know the parameters are alpha, beta, gamma, and the error terms epsilon, u, and v exist because there are three equations, so there are three error terms, and there are exogenous variables L and K, labor input, capital input, and endogenous variables are Y, which is output, G is the first capital measure, and H is an alternative capital measure, right? So it is pretty clear here because these equations explain how those endogenous variables are generated, right, given all the other things. Okay, so we explain those measures are based on capital plus something else. That's the purpose of these two uh, equations. Okay, and maybe I should have explained it in the in class. So there are like you will see those questions later, but so for theoretical analysis, use error terms, exogenous variables, and parameters. Endogenous variables are just results, equilibrium, based on those equations. So they are just results. So theoretical analysis should be based on these underlying structural parameters. But for estimation purpose, computation purpose, you cannot use error terms because they are not observed. Of course, but if you can calculate the error terms after estimating alpha, beta, gamma, then you may use them as a kind of estimator for the error terms. But anyhow, the estimated alpha, beta, gamma must depend only on the observed variables. Okay, so in that case, you may utilize endogenous variables in your computation, obviously, right? So you use those five, you observe, but K is not observed. So in that for estimation, you only use 1, 2, 3, 4, L, Y, G, H. So depending on what you are doing, you have to use the correct variables, correct expressions. Like, for example, in part, I believe part A is too easy, so I will leave that to you. Part D, basically I'm asking you to calculate this covariance is not zero, right? And then you have to use these two equations. These are, so the first equation is a structural equation that explains how G is generated. And second expression is, so epsilon tilde is our new notation, new variable that we defined, but it is defined in this way, right? So the right-hand side is structural underlying variables, but the left-hand side is a result of that or just our like arbitrary notation, right? So you have to replace G with the underlying variables, how it is generated, and epsilon tilde with this, okay? So the endogenous variables are not uh, convenient in this calculation because it's like a theoretical analysis. Similarly, the motivation that I made this question in this exam is a question from a student. In homework 2, a student considered this equation. So set up, like say, capital is a linear function of two measures. They have their own errors, but like it's a kind of a new equation. Like it is similar to the two-stage least squares problem, the first stage equation. Then, so I thought about this. It's really hard to. I could not explain at the time why this is wrong. This approach is definitely wrong, but why? Why? So then, I mean, so it is not wrong. I'm saying it is not natural, right? This is not what I want. So I thought about this, and the main reason is capital is underlying variable. Everything starts from the capital. So after capital generated, then there is an additional measurement error that generates G. So capital realizes first, and then G and H realize later after K realizes. So this the way of explanation is kind of wrong, like kind of unnatural. You are using uh, K as a result and G and H as explanatory variables. That does not make much sense. Usually K generates G, not the other way, right? At least in this question, okay? At least, and for our purpose, in our questions, you do not need this kind of unnatural equation. In some cases, this equation may help, but right now we don't. We don't need it. Okay? So it's like, so it's really hard to explain why it is wrong. Like it's like I say I am a professor, but if I say you am a student, then you know it is wrong because you are a student is right, but you am a student is wrong. But then why? I don't know why. Uh, so because like I put it this way, it is we are analyzing a model, then our and like okay, put it this way. So I am wondering why you don't understand econometrics, why you why your why your grades are why your answers are so wrong. I'm not saying it is just an example. I'm not saying you are wrong. Just as an example, imagine if your answers are wrong, then it is natural to think that oh my lecture was not good enough. My lecture was not kind enough. This is the right way to kind of deduce, think about, infer, make an inference. What is going on? What is the cause and effect? But the other way is not right. Like why econometrics professor is so unkind or econometrics lecture is so difficult. Then I cannot say that's because your answers are wrong, because you are not doing well in the exam. So the cause and effect does not go the right way, like right. So we have to go down to the cause to analyze something, not like this, right? So K is cause and G and H are results, like here. Exogenous variables and error terms are the causes that generate the endogenous variables. So we try to explain those endogenous variables using the underlying variables, not the other way. So this equation is unnatural. I'm going to use this intuition later. Okay. And part C, let's go to part C, specification bias. Um, a term that I did not explain I did not explain in the lecture was estimand. Maybe it would have helped if I use this term. So if you search for estimand on Google, it says it is a quantity to be estimated. Like for example, in the simplest example, this covariance divided by variance, you know this term, is the estimand of the classical linear regression model with single regressor, right? In the simple regression model, this is the estimand. We would like to estimate, this is our target estimation, target of the estimation, because we prove that the parameter of interest equals this guy. So in the ultimately, we would like to estimate beta, but beta is not a statistical object. So we show that beta equals this guy. And then we use the OLS estimator to estimate this, right? So this is our estimand. And then later we show that OLS estimator converges in probability to this guy. And then this equals beta 0 from the proof. Okay, that is kind of another step we could think about. And then this specification bias is the difference between the estimand from the parameter of interest, right? So still, OLS estimator will converge to this guy. That is just weak law of large number. That is still true, but it is different from beta 0. That is um, what you have to do. Like the difference is the specification bias you have to show. Okay. Of course, in this question, the estimand is just this one. Of course, X includes 3 variables. Um, so this is only for single regressor case. So you have to handle the difference between this from beta and gamma. The algebra, maybe this question has a little annoying algebra, but we have done this earlier. You may keep 3 regressors, but then you are going to, so X is 3 regressors, including intercept, L, and G, but that requires 3 by 3 matrix inversion. That is possible, but will be pretty annoying and unnecessary. I would recommend use the demeaned variable approach. Like we learned how to demean the variables and how to just delete one of them, right? Then the matrix is 2 by 2. Then it is still annoying, but much better. And in doing so, it will help if you define some notation like S subscript LL, which is L times L expectation. SLG is expectation L times G, something like that. Or instead of L, you may use the demean variable of L. By the way, you have to explain basically like you have to denote, define new notation for demean variables and just write a couple of sentences, like 1 or 2 sentences, what you are doing and what would be different. Like for example, intercept will be gone. You rewrite the equation using demean variables without intercept, but the same coefficients and error terms. Okay, so you have to explain that briefly. Okay, And also, by the way, in case if you do not know this notation, three lines or kind of extended equality is uh, identity. Like this is always true because I defined it. It's definition, right? I define SLL as this. So three lines is definition, or right, which is always true. And I said a lot of students make this mistake. This equality holds only when there is only one regressor with one intercept. So in this case, you don't have this equality. You have to do this general thing. But everything else, each variable is scalar, so you just the 2 by 2 inversion is annoying, but that's the only annoying algebra in this step. Part B. So instrumental variable. I believe it is not that difficult. You know what is the exogeneity and the relevance condition. But like for example, when you prove uh, relevance condition, basically you are showing the covariance between G and H. I said you have to move down to the exogenous variables, but like this is not recommended. This is not wrong. Equality is mathematically correct. So replace H with G minus U plus V. This is not wrong, mathematically correct, but as I said again, this is not the right way of analyzing this covariance, right? You would like to analyze how G and H behave, then you have to investigate how they are generated. What are the underlying variables? So I don't recommend this. It replace G with the structural equation and H with the structural equation. And okay, like I would explain this as replace the endogenous variables with more primitive variables, like more underlying structural fundamental variables. Part E, from here, we are considering estimation problem, like some kind of estimation and some kind of identification. So two-stage least squares estimation or fitted value approach in terms of identification. Second stage regression is the main equation, as you see from here. So, right? That is the structural equation. And then, how can you set up the first stage regression? This is kind of unnecessary. We are not interested in the first stage, but we needed to identify the parameters of interest. And remember, the first stage regression is to explain endogenous variables using exogenous variables. So it is called the reduced form equation, or the first stage equation, right? And exactly same terminology as in the simultaneous equations model. In the simultaneous equations model, we started from structural equation, and then we rewrite those equations so that the endogenous variable is explained by exogenous variables. Okay, so and what I wanted to point out here is you have to include all exogenous variables on the right hand side, right? So in this example, H is an instrument for G, but there is another variable L already included in the original equation. That is, L is exogenous, so you have to utilize that in the first stage, okay? And then I believe notation is easy. And after setting up the equation, you have to show that the fitted value is uncorrelated with the equation, the error term in our estimating equation, okay? Equation number 2, okay? So, uh, here, like I wanted to make sure, you may be wondering, so in the first stage regression, we are going to regress G on L and H. So their coefficients will have estimation errors. those estimation errors may be correlated with epsilon tilde. That is right. Right? Theoretically, you can show that, but that will be really small, like approach to zero. But what I'm doing here is I want you to distinguish this. Like our argument, when you say fitted value is uncorrelated with the error term here, that is at the identification level, right? So if you know the first stage regression coefficients, if the first stage regression coefficients are perfectly identified, or you have infinite observations, so you know them, you can estimate them without any error, then you can show that the covariance is zero, right? So uh, like I want you to distinguish the estimation argument and identification argument, right? So in theory, this is a theoretical analysis. Covariance is zero, so uh, we are not talking about the estimation error. And final two questions, part F and G. Part F is to calculate the asymptotic variance. I'm not asking you to prove all the steps. You just, in the end, what you need to do is just apply the theorem to your case, right? That's what you do. But and then G, you need to think about how to estimate the variance, because based on the variance, you are going to calculate the standard error, and from the standard error, you are going to calculate like t-stat, p-value, and do hypothesis testing, things like that. So the main point here is these two questions are at different levels. F is about theoretical variance, and G is about how to compute the variance, right? So as I said earlier, the theoretical analysis use exogenous variables and parameters, right? It's like OLS variance includes variance of epsilon, right? Epsilon is not observed, but that is one of the underlying variables. So you can like express the variance using error terms, exogenous variables, error terms, and parameters, right? However, computation does not allow you to use any unobserved, unavailable objects. So you have to explain how you utilize the observed variables and and estimates, right? So for example, back to OLS example, the theoretical variance includes epsilon. Technically, epsilon is not observed, but you can calculate the residuals based on, so you estimate beta first, and then use the beta to calculate the residual, and then use the residual in the place of epsilon, then you can calculate the variance. So in part G, you have to explain those steps. If you write a code, if you make an algorithm, then you have to uh, do it step by step, and you have to explain which steps you have to do. By the way, in F, I gave you a lemma just so that you can just apply the lemma, but the lemmas are not rigorous because I do not include, I forgot to include some assumptions like finite second moments, or like some, like I don't know, I don't remember exactly what you need. So anyhow, uh, please, but you know what I'm saying. I'm not saying, I don't mind too much about the details about the proofs and assumptions. Right? In this simple model, they are okay. So just apply and just be more careful about your notation, and that'll be enough. Okay. Okay. I have to make, by the way, so just additional question that I considered, but I did not include, is hypothesis testing. Like in this example, it would be interesting to see how you test the constant returns to scale of the production function. If your null hypothesis is a constant return to scale, that means beta plus gamma equals to 1. So can you test it or not? Could be an interesting question. But I did not include that because that may take more time. So, but if you are interested, it would be really nice to think about that. That will be pretty simple after you calculate the variance. Anyhow, okay, I will continue in the next video. I will discuss question 2. See you there.